Hello and welcome to another edition of the Integrated Science Intervention Program for SHS. Today's topic is electronics. In today's lesson, we will demonstrate how discrete electronic components behave in an electric circuit. My name is Kisiwa Edu and I'll be your facilitator. To get us started, do you recall these components below from our previous lesson? Well, which of them does the following? Store charges in a magnetic field, resist the flow of electrons, store charges in an electric field. Well done. Resistors resist the flow of electrons. Capacitors store charges in an electric field. Inductors store charges in a magnetic field. In our lesson today, we would learn to interpret circuit diagrams. Then we'll go on to relate to how circuit components behave in an electronic circuit, namely our resistors, capacitors, and inductors. So to start us off, we would interpret circuit diagrams. We'll demonstrate the effects of the electronic components as mentioned earlier as the lesson progresses. Some of the key words we will encounter in our lesson today are light emitting diode or LEDs, direct current or DC, alternating current or AC, series arrangement. Now when we talk about series arrangements of components in a circuit, it is when we put components end to end on a circuit. We connect from the positive side to the negative side. We would also see parallel arrangements of components. Now in the parallel arrangements, we put them side by side. What I mean by side by side is that in a parallel arrangement, all negatives go to one side and all positives go to another side. We'll see connecting wires and a breadboard. Now let's begin by learning to interpret our circuit diagram. This is a typical circuit diagram you would find in your science textbooks. How do we translate this circuit diagram into the real diagrams that we see in our everyday electronic experiments? To start off, you have to pick a starting point. In this case, we would want to pick our battery as our starting point. The positive end of the battery, the black line you see there, is a wire that connects the positive end of the battery to one end of the resistor. The other end of the resistor is connected to the positive side of the LED, and the negative side of the LED connects back to the negative side of the battery, and that completes the loop. Now when we are done with this is how it looks like. Please join me as we have a practical section on how this circuit looks like. Welcome to our electronic working space. Just as we mentioned earlier, we are going to see how we put together a simple electronic circuit. To enable us do that, we have two dry cells. Now when we put the two cells together, we form a battery. We have a resistor, an LED, and some connecting wires. To create a battery, we are going to connect the negative end of one of the cells to the positive end of the other. This arrangement is a series arrangement. Now like we said, we look at our circuit diagram and pick a starting point. Our starting point for this circuit will be the battery. We are picking from the positive side of the battery. So we pick the positive side of the battery. I need to put in another connecting wire so that I'll be able to join the battery to the resistor. So from the positive end of the battery to one end of the resistor. The free end of the resistor goes to the positive end of the LED. Now the negative end of the LED goes back to the negative side of the battery, and there we have it. Our LED is glowing. So this is what I would call an already made circuit. So before we get here, how do people in the field of electronics plan out their circuit to get this? Let's have a look. This is what we call a breadboard. Now you can compare this